In biology, a population is a group of individuals belonging to the same species that live in a specific geographic area and interbreed, though defining geographic boundaries can be challenging for some species. Population genetics studies genes in animal, plant, and microbe populations to understand migrations, relationships, and adaptations, using statistical methods to analyze gene distributions. In anthropology, particularly physical anthropology, a population is a group of people whose origin, evolution, and diversity are studied. These studies consider human evolution, variations, and the biological basis of human behavior, examining both past populations of fossil hominins and non-human primates. The processes that differentiate people into geographic populations include natural selection, mutation, genetic drift, migration, and genetic recombination. Population: in human biology, the whole number of inhabitants occupying an area, such as a country or the world, and continually being modified by increases, births and immigrations, and losses, deaths and emigrations. As with any biological population, the size of a human population is limited by the supply of food, the effect of diseases, and other environmental factors. Human populations are further affected by social customs governing reproduction and by the technological developments, especially in medicine and public health, that have reduced mortality and extended the lifespan. Few aspects of human societies are as fundamental as the size, composition, and rate of change of their populations. Such factors affect economic prosperity, health, education, family structure, crime patterns, language, culture. Indeed, virtually every aspect of human society is touched upon by population trends. The study of human populations is called demography, a discipline with intellectual origins stretching back to the 18th century, when it was first recognized that human mortality could be examined as a phenomenon with statistical regularities. Especially influential was English economist and demographer Thomas Malthus, who is best known for his theory that population growth will always tend to outrun the food supply and that betterment of humankind is impossible without stern limits on reproduction. This thinking is commonly referred to as Malthusianism. In biology, a population of organisms is a group of individuals of the same species, defined by a discontinuity or disjunction from other groups of individuals in certain characteristics, such as living area, genetic attributes, demographic structure. Among biologists, the term definition varies, in some cases significantly, and sometimes those variations can be confusing. There are also plenty of other terms to describe groups of individuals if no clear disjunction is present. Commonly, a population can be described by what individuals constitute the population, its size, a geographical area it occupies, and the time within which the population is examined. In qualitative terms, it is usually defined like a group of organisms of the same species occupying a particular space at a particular time. The two main approaches to define a population are ecological and evolutionary. From the ecological perspective, individuals are considered interacting and competing in a certain geographic area. From the evolutionary, genetic, perspective, genes and reproduction are considered the driving forces of a population. Since each population has its own gene pool that changes and adapts to the environment over time, the population is considered to be the main organizational unit in biology. There is no standard terminology to define a population, but there are many definitions of this term. Aside from biology, a population can be commonly defined as a group of units. In biology, those units are individuals. And such a group is separated from other groups by some characteristics, i.e. disjunct from other groups. Populations can be demographically, spatially, or genetically disjunct from each other. Before the 1940s to 1950s, the population term was used by biologists and ecologists to describe multiple species of a region, like a population of birds, but the term evolved and is not used this way anymore, describing only members of the same species. Although the term polyspecific population was proposed by some ecologists, but in ecology, the term community is generally used to describe multiple species of a region instead. Also, there are at least 30 other terms to describe a group of individuals. Some of these terms were introduced because the definitions of the population term were not clear. If individuals of a group are semi-isolated from other groups, or they are more genetically similar, then the term "deme" can be used. Groups that are not disjunct from other individuals can simply be called groups, or they also can be called subpopulations or local populations. For individuals that are spatially closer to each other than to other individuals, the terms aggregation and cluster can be used. Spatially separated populations of the same species can be called a metapopulation. And all the populations or metapopulations of a species can be called a species population. In biology, particularly, in evolutionary biology, a population is sometimes defined as a set of individuals that interbreed or that are able to interbreed. In this context, interbreeding individuals are those individuals that can produce an offspring with combined genetic material from both parents. Different populations of the same species are also able to interbreed. But if there are some barriers that prevent interbreeding between different populations, such barriers are called reproductive isolation. In context of these terms, a species can be defined as a group of one or more interbreeding populations when such a group is reproductively isolated. Use of the term. In ecology, a population is a group of organisms of the same species which inhabit the same geographical area and are capable of interbreeding. The area of a sexual population is the area where interbreeding is possible between any opposite sex pair within the area and more probable than crossbreeding with individuals from other areas. Ecology studies populations of different species rather than populations of a single species. Such populations as a whole constitute a community. Each community consists of populations of animals and plants that live together, interacting and being dependent on each other. So in ecology, a population of a single species is studied in the context of a community. In ecology, the population of a certain species in a certain area can be estimated using the Lincoln Index to calculate the total population of an area based on the number of individuals observed. Census, being defined as a complete count of individuals, is rarely possible to conduct in large populations, but it can be useful in small populations that are easy to count, particularly in applied ecology. Population dynamics is the type of mathematics used to model and study the size and age composition of populations as dynamical systems. Population dynamics is a branch of mathematical biology, and uses mathematical techniques such as differential equations to model behavior. Population dynamics is also closely related to other mathematical biology fields such as epidemiology, and also uses techniques from evolutionary game theory in its modeling. In genetics, a population is often defined as a set of organisms in which any pair of members can breed together. They can thus routinely exchange gametes in order to have usually fertile progeny, and such a breeding group is also known therefore as a gamodeme. This also implies that all members belong to the same species. If the gamodeme is very large, theoretically, approaching infinity, and all gene alleles are uniformly distributed by the gametes within it, the gamodeme is said to be panmictic. Under this state, allele, gamete, frequencies can be converted to genotype, zygote, frequencies by expanding an appropriate quadratic equation, as shown by Sir Ronald Fisher in his establishment of quantitative genetics. This seldom occurs in nature. Localization of gamete exchange, through dispersal limitations, preferential mating, cataclysm, or other cause, may lead to small actual gamodemes which exchange gametes reasonably uniformly within themselves but are virtually separated from their neighboring gamodemes. However, there may be low frequencies of exchange with these neighbors. This may be viewed as the breaking up of a large sexual population, panmictic, into smaller overlapping sexual populations. This failure of panmixia leads to two important changes in overall population structure. 1. The component gamodemes vary, through gamete sampling, in their allele frequencies when compared with each other and with the theoretical panmictic original. This is known as dispersion, and its details can be estimated using expansion of an appropriate binomial equation, and, 2. The level of homozygosity rises in the entire collection of gamodemes. The overall rise in homozygosity is quantified by the inbreeding coefficient, F or phi. All homozygotes are increased in frequency, both the deleterious and the desirable. The mean phenotype of the gamodemes collection is lower than that of the panmictic original, which is known as inbreeding depression. It is most important to note, however, that some dispersion lines will be superior to the panmictic original, while some will be about the same, and some will be inferior. The probabilities of each can be estimated from those binomial equations. In plant and animal breeding, procedures have been developed which deliberately utilize the effects of dispersion, such as line breeding, pure line breeding, back crossing. Dispersion-assisted selection leads to the greatest genetic advance, delta G equals change in the phenotypic mean, and is much more powerful than selection acting without attendant dispersion. This is so for both allogamous, random fertilization, and autogamous, self-fertilization, gamodemes. According to the UN, the world's population surpassed 8 billion on November 15, 2022, an increase of 1 billion since March 12, 2012. According to a separate estimate by the United Nations, Earth's population exceeded 7 billion in October 2011. According to the United Nations Population Fund, UNFPA, growth to such an extent offers unprecedented challenges and opportunities to all of humanity. According to papers published by the United States Census Bureau, the world population hit 6.5 billion on February 24, 2006. The United Nations Population Fund designated October 12, 1999 as the approximate day on which world population reached 6 billion. This was about 12 years after the world population reached 5 billion in 1987, and 6 years after the world population reached 5.5 billion in 1993. The population of countries such as Nigeria is not even known to the nearest million, so there is a considerable margin of error in such estimates. Researcher Carl Hogg calculated that a total of over 100 billion people have probably been born in the last 2,000 years. Population growth increased significantly as the Industrial Revolution gathered pace from 1700 onwards. The last 50 years have seen a yet more rapid increase in the rate of population growth due to medical advances and substantial increases in agricultural productivity, particularly beginning in the 1960s, made by the Green Revolution. In 2017, the United Nations Population Division projected that the world's population would reach about 11.6 billion in 2050 and 24.8 billion in 2100. In the future, the world's population is expected to peak at some point, after which it will decline due to economic reasons, health concerns, land exhaustion and environmental hazards. According to one report, it is very likely that the world's population will stop growing before the end of the 21st century. Further, there is some likelihood that population will actually decline before 2100. Population has already declined in the last decade or two in Eastern Europe, the Baltics, and in the former Commonwealth of Independent States. The population pattern of less developed regions of the world in recent years has been marked by gradually declining birth rates. These followed an earlier sharp reduction in death rates. This transition from high birth and death rates to low birth and death rates is often referred to as the demographic transition. Human population planning is the practice of changing the rate of growth of a human population. Historically, human population control has been implemented with the goal of limiting the rate of population growth. In the time from the 1950s to the 1980s, concerns about global population growth and its effects on poverty, environmental degradation, and political stability led to efforts to reduce population growth rates. While population control can involve measures that make people's lives better by giving them greater control of their reproduction, a few programs, most notably the Chinese government's one-child per family policy, have resorted to coercive measures. In the 1970s, tension grew between population control advocates and women's health activists who advanced women's reproductive rights as part of a human rights-based approach. Growing opposition to the narrow population control focus led to a significant change in population control policies in the early 1980s. Thank you for watching this video.